So marker in place, ready for our VOD. We're creating a sprite batch inside of the image. Now, what I'm thinking of doing is taking a lot of the lessons learned and applying this to a brand new branch, because we've done a lot of questionable things in this branch just to try to sort of get it working. So it might be good. Now, I'm going to keep this other branch as long as I need it. Where did I put it? Oh, I haven't loaded it up yet. That's why. So we have improved performance in Pi. I want to come back to main, create a new branch, and we're going to do this 25. And so the first thing that we're going to do here is sprite batch the hearts. And that should give us a little bit of improvement there. And every little bit of improvement that we can squeeze out of this is going to help us out quite a bit. All right, I'm going to go ahead and just push this on up right away so that way we can get those CI tests working, and it will let us know in case things are terrible later. All right, so with that, how do we want to do this? I'm thinking now that we want the image system to maybe handle the draws. Right now we have, I mean, is that completely true? I don't know. Right now we have draw systems, and we don't have a draw system for the, what is it? For the hearts. Instead, we just sort of have these game objects, and they implement the draws and everything else for them. So we can see, do we even have something like that? How are we drawing those out? Oh, the player is drawing out the number of hearts, isn't he? Right here. So the player is drawing the hearts. And I wonder if it would make sense to separate this out. Instead of the player taking up all this extra time to create this, in our update loop, we set up the sprite batch. And then in the draw loop, we just draw out the sprite batch. So we're gonna need, we have the player life system set up for us. That is under life system here. And we can get the lives. So if we find the player in the update loop, we can get the lives out. That could be in the main scene. And then from the main scene, we could then ask the draw system for the hearts to draw out. Stacking, hello, did we fix the performance issue? Sort of, yes. I can't, unfortunately, prove it to you because I noticed that the performance drops considerably when I'm on OBS, which is strange because it's just through a capture card. So I think my capture card might be slowing it down a little bit, or maybe it's like the interface for that. I'll have to double check it again afterwards. I turned it off overnight, the Raspberry Pi, so it's possible that like on reboot it reset the drivers or something, and they need to go back and like change those again. But I'm thinking that it should be back to like, it should be working on normal usage. I also do remember that I have a TV downstairs that is, it's not 1080p, so that might not be the best resolution. Is it 1920? It might be 1920. It might be 720p. I can't remember off the top of my head. I need to go like look up the documentation for that TV to see if like it's a good one for me to test on. But all right. So in the main scene, I want to pull the number of hearts that we have, the life count that we have, and then I want to tell the draw system for the hearts to live. And that means that we're going to want to add the hearts into game objects. We want to track it through game object. So that's what we're going to have to do now, is we're going to have to set up game object so it can handle hearts. If we take a look at a game object here, we can actually write a test for this to sort of like see how exactly it's going to work. So let's do a test. Function. Let's try this as a CI test and see how it goes. CI test, create hearts. Run into a short meeting. Hopefully be back soon. Well, good luck with your meeting. Have fun. And we'll see you back when you're done. Okay, so CI test create heart. It's really just going to be like a single game object that represents all of the hearts. So I think that's going to be interesting for us. And because of that, our position for this, it might be easier to throw this in a top left math-wise. And the reason for that is as we subtract hearts or add hearts in case the player is able to, like, I don't know, add a heart. We haven't decided if we have that system yet. We just add them in. We don't have to do the math to like reposition to the left. I don't know, like that may not be a problem. We might, yeah, maybe we don't actually need to worry about that yet. Okay, so to create a game object, let's just start sort of like, and basically see what we need to do. Well, actually we already see what we need to do. We need a location for it, and that's going to be a point to. So that our location is going to be equal to a point to new. And I mean, we're running a test. We don't really care what this is. It's going to be 50.0 and 50.0. We also know that we need a width. So width equals, we need some kind of draw system for this. It can be a none for right now, but we're going to want to fix this later. So we need a draw system. So let's come into here, add in U. This is going to be the heart. Maybe we should call this the life draw system. Is that, no, I want a hearts. Hearts draw system. All right, so before we can get onto those tests, we have to start writing these tests and figure out like how we want to actually draw this to the screen. All right, so okay, so CI test, create art draw system. All right, what do we want to do here? So let art draw system equals probably something like heart draw system new. And then we'll leave that there. To make this work, we need to open up mod here and bring that in. All right, let's get you going. Okay, so that technically makes it work. The nice thing about this is that we can create a new draw system off of this for that other test. I don't know if that's really helpful here though. Because like as we write those other tests, as we continue like building out this draw system, we're gonna need to build it to test to update that. I don't know, because it's like a chicken and egg thing. I don't know how to I don't know what needs to go in here necessarily. Well, you know what? There's one thing we do need to do. We need to implement draw system for part draw system. Implement those missing members, and then that gets us a nice to do here. So that will crash when it fails, which means we can come back to our game objects and create our draw system. Okay, so that gives us a draw system. A life system, the hearts themselves shouldn't have a life system. So that's going to be a none, which means we don't need to add that in there. There's not going to be a physics system for it. So at that point, we can just build. So let hearts equals game object builder new. Okay, so location is location. Width is going to be our width. We have a draw system, which is, let's see, box new draw system. And no life system, no physics system. We could then .build and unwrap. So just running this should work, and that should be the appropriate test. We can also test that. And we've already tested the other things, so I think it's really more of we just want it to be able to work. I mean, in that case, does this really even need to be a test? It's more of documentation of how to create a heart. I think this would be more of how do we create a yeah, I think I'm gonna undo that. In the main scene, we want to create our hearts and add it into the draw system. So let's head over to the main scene. Here's where we want. So when we create a new one, now we have player of game object. I think what I want to do is have just be game objects, and you be a vec of game object. That's obviously going to create a bunch of problems. So let's fix those then. Then what I'll be able to do is create our, see, this is the player, well, is this. Oh, you're matching off of that to get the player. We can then, at this point in time, is create the heart game object and add it to the game objects vector. So that'll be nice there. Okay, so if you are game objects. So game objects is going to be a vec. And I think we should create that up here. You need to be mutable. So that way I could then push game objects straight into here. Okay, so you're happy. Is player off screen to the right? So here we need to find the player inside of the vector. In order to do that, we're gonna need like a find player, which means we need the type. And we were talking about this a little bit yesterday. And I don't think, yeah, this branch we haven't done anything about that. So let's go ahead and start figuring out like how I want it out. It's going to be part of this new test. We're going to want to add to game object builder. So before we build a dot with or as type, and then pass it in some kind of type here. So do that right here. Pub enum game object types. We're gonna have a player to begin with, and we also know we're gonna have a heart. And this might be a static game object, but it might not be also. Okay, so as type, game objects types, player. Okay, so you don't exist yet, so we need to add you in. So as type. You're gonna take in a mutable self and return a self. So we'll just return self right now. We also need the new type is a game object type. Okay, so we're gonna do that. Then we're going to assert equal the player dot player type. Oh, game object type is going to be game object types player. Well, you're obviously going to be immediately unhappy because that, there's no field game object type on there. All right, so game object types. That's going to be necessary on top of the game object. Now, when we create the builder, however, we're going to need to put this in here, which means we need to store that in here too. So you can be game object type. This can be an option game object type. The main reason it's an option is because I do want it to be necessary to have. And we're gonna start it off by none. Which means if it's not set by the time we do build, that's gonna be a problem. Send in here and build. We have a game object type, self dot game object type dot unwrap. And then the rest of you is partial equal needs to be added to game object types. And I think also debug. Yeah. All right, so that should technically be happy, but we have a lot of other problems to get through here. So because we have the type, when we create the player, let's see. When we create the player here, we have to add in the type. As type. Okay. We tell it that it's the player. Now, we could have a function off of game object to get object by type. Or maybe even like get objects by type. In reality, it's just going to be looping through the vector until we find this this type, and then we're gonna play with that. So let player, and we don't need writing access to it. So let player equals self dot game objects dot. Is there a find? Can I iter dot find? Ooh, there is. Okay, so I can find. We have a predicate. So we're gonna get a game object. I noticed this is like a double reference here. That's fun. I might have to dereference this. We'll see that. And then if the game object, okay, so if the game object dot you need to be public. And I wonder if this should be a test. Although I think I already have that. I do. So if this still works, then all this code is good. Game object type. Okay, so if that is equal to game object types player. I can do that because we have partial equal set up, so I can just straight up equate this. That gives us an option here. An option to a reference of a game object. Then we can do a if let sum. Now I can do the if let sum straight off of here, but that might be a little bit more confusing. Okay, so if that's the case, then we're gonna get the we're gonna be able to extract out the the player from here. We get the config resolution. Okay. If this doesn't exist, what should my default be? Should I basically just do false? Or should this be an option that gets returned? I think we should just return false if we can't find the player, or we should completely fail, because this should not ever happen. So, what is it called when it's where you can't get to the code? It's not unimplemented. It's not I forget. Unreachable. That's what it is. Unreachable. Okay, so this, instead of player, this becomes, or instead of self to player, it's player. We're going to do the exact same thing here. Okay, self.game objects, iter, that find. We have the predicate of the game object. Game object dot game object type is equal to and then we can return this. And we'll do our if let sum player equals player. And do that, else unreachable. Okay. You don't become self player, you're just player. And you're that too. All right, slowly moving forwards. In update, so instead of this self.player update, we want to, we're gonna want to just move to loop through our game objects. So we want to do self dot. Keep that up here right now. There's no error that could possibly happen here, so we can do a self dot game objects dot iter dot for each game object, and then we can do a game object dot update and pass it in the command. And that should be happier now. All right. If self is player off screen. Okay, so is player off screen to the right, then tell the map to move right one position. And then move the player's location, reset the player's location again. Kind of wonder if this should happen in the physics engine. Now, how we're going to get the map to move could be a channel. That could be a good way to like do a message. And so like an event system might be good here. We could pass the map in to the physics system. But I think it might be, for right now, I think we'll just keep it as it is, and we can refactor this later. Okay, so self, map, move right. Then we have to update the player's location. So that means we have to extract the player out of here. So before I get too far, I want to like question using a vector for this. Because I could just have, like for the update loop, it's really nice. But for each of these like one-off things, it's a lot less nice. But what I could do instead of a vector is I could use a hash map. So what do we have here? We have like the hearts. We're gonna have the trees. We're gonna have things like pits. My other choice is player could be separate. I mean, it's still a game object. Player could be separate. We could have interface, like the background stuff. So that'd be like trees. And then we can have interface things, and that's getting maybe a little bit too much. Since we're repeating objects around, I'm thinking maybe a hash map might be better. Then I could just extract the player directly. So what would happen if I did this? Turn you into a hash map. And we have the type. Goes here. Now it can only have one type of each. And then the game object goes here. And maybe that would work out a little bit better. And so what would this mean? It would mean that we don't need to store the type inside of the game object anymore. So we can come back to here and rip out all this stuff. Don't need you. Don't need you. Don't need you. Don't need you. And don't need you. Okay, so then you should be... Don't test for you. Okay. So if we have game objects like that, then game objects, instead of a vector, you're going to be a hash map. New. We're going to create our player, and then we're going to insert. The key is going to be a game object types player, and the value is going to be the player. We're going to be an ownership to the hash map here, and there's the game objects. So you're happy. Now, is player off screen to the right? I think something that would make a lot more sense is not only are we bringing in the config, but let's bring in the player. This will make it a lot simpler and back to sort of what we originally were having. So we're gonna have player here, and that's going to be a type reference to a game object. So we can pretty much put this, we don't have this code to sort of find it anymore. We don't need this if let. We're just gonna do the math here. And so we'll update you too. All right, so that'll be the same here as well. In our update scene for this, we can still iterate through a hash map. So self.game objects, the iter for each. We get the game object. Now, what are you upset about? Implementation is not supporting. Because I deleted one too many closing brackets. Okay, so to get if the player is off the screen to the right, we need to extract the player first. So we're running update, and you need to be a tuple here, so we can get game object and game object type. Which I don't think we care about what you are right now. So we'll just leave you as an underscore temporarily. Now you need to be mutable, I think. Get her mute, then we can run the update on you. Then we need to extract the player out. And so this is like one of the things that could potentially fail, I suppose. But we should always have a player at this point in time. So let player equals, we probably want to crash if there is a player, or at least return some kind of a game error. So let player equals self dot game objects dot. Is there a find or extract? I don't want to remove. There's get. And I don't need to get it based on returns a reference to the value to the corresponding key. Okay, so I just pass in the key, which is going to be a game object types player. So get me the player, and it gets me an option here. We can unwrap this for right now. But I think I want to expect, so I can have a message for this, which is going to be could not find player. It will give me the line number, so that'll help out here. Let's see. No method name get found for. Oh really? Oh, we need to pull in the right get game objects. Okay, Q sized, huh? Q is hash, and K is the borrow. Oh, K is the key. Let's see. A couple things have happened. Sure Shock, did I manage to make the Pi work? I did manage to make the Pi work, but not through, like, just plugged into my monitor directly. And there's a couple things we went through, but also Peyton Rules rated with a party of 7. Hello, Peyton Rules. Hello, Raiders. Welcome, welcome, welcome. Thank you so much for the raid. Thank you for coming here. B Porter, hello. Okay, so there's a couple things that I ended up doing for the Raspberry Pi to make it work when I was plugged it directly into my monitor. I haven't gotten it to work when I plugged it into a capture card to go into OBS, which is a little bit weird. It might just be my capture card is not right. Or something else is going on. Basically, I also noticed that when I'm in my capture card, my mouse is slower. Like the entire Raspberry Pi is slower. So there's something weird going on just outside of the game. I set the resolution of the Raspberry Pi to 1920 by 1080 with a refresh rate of 30 hertz. That's matching what the game is going to be. I also switched over to the new Vulkan drivers, and I removed a bunch of the meshes that we're drawing out and replaced them with images. Doing all of those brought me down below 30 milliseconds for the draw function each iteration through the loop. So I can add in more images pretty easily, but I can't add in meshes. So taking those away or like making our draws of images much more efficient is going to help out a lot. So that's what we're doing here is we're refactoring to allow us to do that. So I'm trying to figure out a way to extract the player from the hash map of all of our game objects easily. Now, it might make more sense because like player is pretty unique. It might just make more sense not even to do this as like separate game objects. Maybe I should just have this as like player equals this, hearts equals this. Maybe like that will be a lot easier definitely than having to like go through and like check for game objects like this. If I want to, because I'm trying to get and extract the player out of here using game object types. Well, apparently there's apparently no get for game for hash map, which is sad because that's what I was getting from. That's what I was getting from. What is it called? The Rust Analyzer. Oh, do I have to turn it into an iterator first? Iter, and then can I do get? No, okay, so there's not that either. That. I don't want to remove it. See, here's this get right here. Public function get. Returns a reference to the value corresponding to the key. The key may be any borrowed form of the map's key type, but hash and equal on the borrowed form must match those for the key type. Wait a second. So do I need to do like a reference to game object types player? And this is where we're saying no method named get, which that's like a different. Oh, the method get exists, but the following traits are not satisfied. Game object types compare equal, and game object types hash. Okay, so I need to derive those in here. Then you work. Okay, got it. So that gives me the option of this. And we can go ahead and expect this. Could not find player. Because it shouldn't be possible not to find the player for this. Sure Shock, you redeemed Pet the Cat 6 minutes ago. But Kitty Cat's not in here, unfortunately. So I can't pet the cat. Let me go see if the kitty cat's just right outside the door. I'm back. And we have a kitty cat. Oh no, I forgot to do the raid game. I do the raid game still. I was just sort of really super into this. That's why. We could do let's do the raid game. Do I have... Oh, I want to set up something for the my stream deck so I can start the raid game. But do you want your toy? You do. Oh, you're super tired. He wants to play with it, but then he just hugs it and hugs it and just starts falling asleep. All right, let's do ourselves a raid game. I did at one point in time. Oh, I've been trying to figure out ways to like to start this. I haven't. It's okay. It's okay. He just started coughing and not feeling very good. So hold on a second. All right. My wife is taking him to take care of him. I don't know what that was. And he just stopped. That makes you want to have another kitten. He's okay now, but that was a little bit scary. It almost looked like a asthma type of attack. All right. Can't be that one. Has to be this one. Documents, code, builds, workspace, streamer game. Yeah, so I set up something to like try to work on it. I apparently need to be CD'd into a certain directory, or I need to put the assets into like a more centralized place so I can launch it anywhere. And then I could launch it easily. So do a cargo run release. All right, so let's play the Get the Streamer game. So if you're new here and you haven't done this, you're gonna do commands in chat to try to get me, as it were. I'm gonna try to avoid you. Can you just make a shortcut and keep the main executable in that folder? It's a good question. I was trying to make a shortcut that I could run off of like a Stream Deck to tell like, hey, Stream Deck, go launch that file, and it didn't work. So maybe I can try that and just put it down here on my down here. That might work. Oh. I almost got away. Am I getting better at this game? I don't know. I'm lasting a lot longer than I normally do. Oh, I couldn't get away from that one. Oh man. I was trying to figure out where to go and I didn't quite get that one, Grub. Thank you everybody for playing that game. That was a lot of fun. Mig and B Porter. Welcome to the Get the Streamer game. Glad to have you here and part of that. All right. So what all right, what are we doing here? Is the player author? Okay, so we have the player here as a reference to a game object. So now we're going to pass in the player, which is a reference to the player which we have right now. And then this will also be, we need to reset the player here. Well, now, okay, this needs to be mutable. So this needs to be get mute instead. And then we just update the player location. Okay, so everything else moves pretty much the same. We hand the player over. And we do that. Okay, so that makes you happy. Now in draw, we want to loop through all of our game objects and run the draw method on it. So that's actually going to be easier than what we have here. And I did remove, so we have, yeah, we moved the update command from before. So this will be self dot, looks like this, we do have mute self, and draw is taking mute self. So we need to mute iter off this. So self dot game objects dot iter mute, dot try for each, and then we're going to have our predicate here, or our function. So we're going to have our key, which is the type. We don't really care about that right now. And then the value, which is going to be the game object. And then for each of these, we want to take the game object, and then run the draw method. Pass in context, pass in the config, and pass in images. And then, well, we can actually just straight up return the result of this. So that brings this down to, oh, we still need the map.draw, but player.draw. Now when we add the heart in, it'll just automatically draw the heart for us. So anything else we add in here will be good. All right, up here, command, cannot move command out. And a closure, so update needs, oh, it needs an option command, and command is already an option command. I could clone it. Command is type, option handle input command, which does not implement the copy trait. So we could go do that. So go to here and implement the copy. All right, what's next? All right, so is self off screen to the right. This will just be you should be fine. Cannot borrow dereference self is immutable because it's also borrowed as mutable. Oh, okay. So on line 67, we borrow it here with self. to get the player out. Interesting. I didn't want to like keep self because it's already immutable. So I would not expect me to have to do this. It's mutable because also borrowed is mutable. Like I kind of want. Oh, is it maybe just because getting the player is like getting a mutable reference to the player is a borrow already. So if I want to borrow it again to run this function, now I wonder, would it make sense to have this like off screen to the right or off screen to the left? Would it make sense to have that be on the game object? Now that being said, that might still have a problem with this self.map, because if I tell you to move right, oh, you don't care about that. Just here. And you're also a dereferenced self. Can't do that. Mismatched types, expected bool, found mutable reference to bool. I can't. I don't think dereferencing it helps here. Type bool cannot be dereferenced because it's dereferencing the result of this. I think something that will help out here is we move is off screen right and is off screen left into the game object. So that would be adding a new test here. So is off screen right. Now right now is width optional. It's not optional. We must have a width. Okay, so that makes it easier. So we can create a game object, and then we can test to see if it's off the screen. If I make the draw system optional, then this test actually becomes really easy. I don't need to like create a draw system for this, which means I don't need a config. I kind of want to do that. I kind of want to say, just like let, we need a location, okay. Oh, and they were going to pass in like the width of the screen into it. So we can even control that too. I like that a lot more. All right, so let's start with this. We're gonna need a location. So location equals 0.2 new. Let's give ourselves like 50.50. 50.50. We need our width. If we set this to be 5.0, and we can now play with this a little bit. Then we don't need lives because we're not going to have lives in this. We're going to try to make it so we don't need a config. We're going to create our game object now. So let game object equals game object builder. Okay, so give it a location. Give it a width. I want to give it no draw system, no life system, no physics system. So then I want to build it and unwrap that. Now we have 11 errors, so I can't actually test that this is working yet. So we can just continue, finish writing this test up. And then if it fails, at least we'll know exactly where and exactly why. We expect that if we run this off screen to the right, and our left side of the object, okay, so we need a screen width. So let screen width equals, we can have this be, here's our location. If we have this be at 50, then we will be off screen to the right. So 50.0, just barely, but we will be off screen to the right. And we don't have a height necessary for this. So we're going to assert equal that game object dot is off screen right. We're going to need to pass in the screen width, and then we'll have the game object itself will already have the width and the location inside of sort of this inside here already. And then we expect this to be true. Other tests that we can do. We could mutate the game object. Or we could just do this as a separate test. So copy you is not off screen, right? Creator location, we'll just do this as you should be like 25 on our X. Everything else is the same. This should now be false. And then we're also going to want an is off screen left. Oh, you're of course upset because we need to implement this. So let's do that. So here's okay, is off screen right. It's we need just a reference to self, and then we need the screen width. That's an F32, and we're going to turn a Boolean. I think I like putting this onto the game object a little bit more. All right, so is off screen to the right. Basically, we're going to test if the top left of our... Well, that's going to be interesting. Our position is... Oh, we realized we changed. Our position is going to be based upon the center of our object, isn't it? So we need a little bit less than half of that. So our test here needs to change. We need our location to be 50, like 52.5. So at 52.5, that's when we should be off the screen to the right. And of course, to the left of this, we should be fine. Okay, if the middle section plus half of the width. That would be our left-hand side. So if the left-hand side of us is to the right of the edge of the screen. So let's get the left-hand side of us first. That's going to be self.location.x minus self.width divided by 2.0. If that is greater or equal to the screen width. And that's what we return here. So that makes you happy. And then we can do the exact same test for to the left of. So is off screen. We want you left. Okay, so location, I want you to have an X of negative. We want the right-hand side to be left of this, which means it's negative 2.5. Because that's half of the width. So we give you the location, the width, the build. Okay, build you. Screen width is 50. That doesn't matter anymore. Is off screen width. We pass in the screen width, and we should, in this case, we don't need to pass in the screen width. We know that the screen is just, well, it's 0 pixels. So we expect you to be true. And for you, I want you to be farther to the left. That should be negative 3.0. Oh, wait, sorry. Negative, well, we could just do 0.0. And you should be not true. So width, we don't need you. We don't need you. And that should be false there. Okay. Okay, so this is going to be the same thing. We want the right-hand side of x. So that's going to be self.location.x plus self.width divided by 2.0. You should be less than or equal to 0.0. All right. So that makes you happy. When this runs, it's probably going to error out because we don't have a draw system here. Because we notice that when we build, we just unwrap the draw system. So I'm thinking for a game object, I want you to be an option too. And that means draw system when we draw here, we have to unwrap it out. So draw that physics state. We just get the physics state. And then if let sum draw system self.draw system, then we run you. Okay, draw system.draw, we run you, we can question mark you, and then run okay like that. So that makes you happier. And then down here under build, we don't have to have an unwrap anymore. This just becomes self.draw system. and we set you to start with draw system none. So now there's less unwraps, which is really nice. All right. And then that means all of that was that we can now, instead of call if self.isPlayer off screen, we can now replace this with, because we have the player now, if player dot is off screen right. We have to pass in the screen width, but we have that with config dot resolution x. And so if the player is off screen right, tell the map to move right, and we tell the player at its new location. Else if, so then we're going to do the same thing here. Player dot is off screen left. Do the thing. And then we have our tests that need to be updated. Right, because we don't have a main scene dot player location. So test moving player off screen right, we don't need that test anymore. That's being taken care of somewhere else. Same as you. Same as you. And same as you. Which means we're not even loading. These can... Oh, we're doing create config. Okay, directly. I installed a spell check. Because I was writing a bunch of, like, for my, when I'm writing into the knowledge base, and that is it's now grabbing N algebra and GGEZ and telling me that those are incorrect spellings. Maybe before I go into that, actually, it's probably a good idea if I want to do for game dev, game objects. We want to store the game objects. I think like the big lessons here is going to that full architecture that we learned in the game design patterns, the game dev programming patterns, I think is really important here. We want game objects to have like a draw system, a life system, a physics system, all of those systems, and they all need to be optional so we can easily build and test them separately and individually. So we have that struct game object. So we also want to have like a draw system needs to be an option box of a dyn draw system. And that way we can like build these things without actually necessarily having to have that. So I think that's going to help out a lot. It is 8:25, so I don't necessarily like we have more errors. We have 2 more errors. I wonder if I can really quickly knock them out. Okay, so this is assuming if let some draw system equals self.draw system. What are you upset about? Cannot borrow draw system is mutable, so you need to be mutable draw system. If let some No, no errors. Okay. Does that mean we can run this? Yes. Okay, we're able to run the game. Everything is still happy here. Okay, so now we're this is all in sort of like moving towards like the player is a game object now. I want to have the hearts be game object with drawing separately. And right now they're drawing through the player. So the next time we're here, we're going to want to update the player to draw not so we want to update the hearts to draw themselves as opposed to the player draw the hearts. So that's going to be the next thing they're working on. So I'm going to go ahead and add that in right here. So this is improve performance. Created a new branch to track the real work for this. Next up will be to have the hearts be their own game object that uses a sprite batch to draw themselves to the screen efficiently. And who knows, maybe if I'm able to do all of these together, even with capture card and OBS, I might be able to get very efficient enough to like get down to 30 milliseconds, as opposed to just straight onto the TV. All right, so that will let me know what's up. Let's go ahead and also close all of you down. And let's see, knowledge, we updated you. Draw systems in game objects. And in jungle, we updated you. So this is a work in progress. Adding hearts as game objects. We didn't run the tests yet, but our CI system will automatically run them on the server. I'm hoping that like we can get more CI tests now because I'm making more things options. Okay, so I think we're all good there. It is 8:30, meaning I need to like go get ready for work and actually go start work. So for the day job. So with that, I'm going to switch over to my ending screen. Thank you everybody so much for stopping by and watching. I'll be back tomorrow morning at 7 a.m. Mountain Time, sort of same time this morning, to continue working on this, getting those hearts switched over to the sprite batch. So with that, I hope that you have a wonderful Monday, and I'll see you all tomorrow.